Okay, so let's talk about end behaviors of rational functions. So remember with polynomials that we found the end behavior by finding the highest degree term, and then we talked about whether the degree was even or odd, the leading coefficient was positive or negative to determine what the end behaviors were. And you can see I copied the chart and posted it in the guided notes so you can recall what that was. You can also remember, if the degree is odd, the end behaviors act like basically y equals x if the coefficient's positive, and y equals negative x if the coefficient's negative. And if it's even, it acts like x squared and negative x squared on the end behaviors. So when you're dealing with rational functions, there are going to be three possibilities for the end behavior. And those three possibilities are going to be basically the following. The first is that your end behaviors can go to infinity. This means just like the polynomials, that as x goes to infinity or as x goes to infinity or negative infinity, y goes to one of the infinities as well. And we'll talk about how to analyze that. The second is that there can be, as x goes to infinity, the y can go to 0. Now we have a special name for this. When as x goes to an infinity, the y gets close to a number. It's essentially what we had when we have exponential functions. We said the exponential functions got closer and closer to 0 as you got closer and closer to negative infinity. When we have that, we draw on the end of the graph what's called a horizontal asymptote. Remember, that's a dotted line that the graph gets really close to but doesn't touch. And that horizontal asymptote would be at y equals 0, which is essentially the x-axis. And your third option is that your end behavior can go to a different number. Now, we're going to talk about how these three things happen in the next video, but this would mean there's a horizontal asymptote at y equals whatever that number is. So those are the three possibilities for end behaviors. Now let's see what this looks like in reality. So I've got a problem here. I'm going to find the end behaviors of this function. So I'm going to start by building what's called an end behavior model. We talked about that with polynomials, that it's the highest degree term on top and bottom. So the first thing we're going to do is build an end behavior model. And we do that by taking the highest degree term from the top and the highest degree term from the bottom. So my end behavior model here would be x squared, because that's the highest degree term from the top, and x squared on the bottom, because that's the highest degree term on the bottom. Now, once we've built that end behavior model, we're going to simplify it. Because now we have a monomial over a monomial, so we have things that can cancel. So this is basically x times x over x times x, so that simplifies down into 1. Then we're going to ask ourselves a question. What happens as x approaches an infinity? Well, my end behavior model is 1, and as x gets bigger and bigger or more negative, 1's not going to change value. So basically, as x gets close to an infinity, this value is still going to go to 1. So this means that the end behavior of this function is that as x approaches one of the infinities, the y value approaches 1. And since we're approaching a numerical value, that means we have a horizontal asymptote at that number, at y equals 1. So you build an end behavior model by taking the highest degree term of top and bottom. Then you simplify that end behavior model. And then you ask what happens as x goes to positive or negative infinity, and you state your end behavior. Now, pause the video, but the three things that you do below, if you're still a little shaky on it, you don't have to pause the video and try it. You can just sort of watch me do it. All right, so we're going to take the highest degree term, build the end behavior model for each of these. Now we're going to simplify each of those end behavior models. Then we're going to ask ourselves what happens as x gets really large, and I'm going to let the video play here. So as x gets really large here, you're going to have 1 over a really giant number. And that's going to be a decimal that gets closer and closer to 0. So as x approaches an infinity, y is going to approach 0. For the second one, that's just the number 2/3. So no matter what x is, as x goes to an infinity, y is going to go to 2/3. And then for the last one, this one actually has a number on top of 3. So you're going to have a really giant number, a really negative number, that's being divided by 3. So this is going to go to one of the infinities. In fact, this is going to act like the end behavior of negative 1/3 x, which is a polynomial. So this one, as x goes to infinity, the y is going to go to negative infinity. And as x goes to negative infinity, the y is going to go to infinity. So we would say here that we have a horizontal asymptote at y equals 0. Here we have a horizontal asymptote at y equals 2/3. And here we don't have a horizontal asymptote, but my end behavior is this. So that's how you find end behaviors of rational functions.